Today in this video we are going to learn how to test the data by using the one sample t-test in SPSS. One sample t-test is used to compare the mean of the sample with the population mean. We are taking the example of the 80 different students. We have collected the data of their marks and now we are testing it that whether their average marks are statistically different from the on average 50 marks. Now the hypothesis of this statement will be developed in this way. The null hypothesis shows that the mean value of a sample is not different than the population mean that is equal to 50. The null hypothesis is that on average score of the students will be equal to 50. The alternate hypothesis is that the mean value of a sample is different than the population mean, which we have considered in this example. 50 means the alternate hypothesis shows that on average the students' marks are not equal to 50, but it could be less than 50 or it could be more than 50. So make it easy. If the p-value is less than the 0.05, then we are supposed to consider the alternate hypothesis, and if the p-value is more than 0.05, then we are supposed to considering the null hypothesis. Let's test it. This is the data of 80 different students and their marks. Students have secured different marks. It is even clear from the data that most of the students have scored more than a 50. But let's test it statistically by using the one sample t-test. Click on analyze and then compare mean. Come to the one sample t-test. It is asking for the target variable or the independent variable, which is in this case is marks. Okay, so you are going to compare it with which value? In this case we are going to compare it with a 50. We are going to test whether the average marks of the students is equal to 50 or not statistically. Okay, so this is the outcome of the result. On average the students have scored 70.63. We can find it from here also that it is not equal to 50. It is different, but in the second table we will able to know whether it is statistically different or not. For this purpose we consider the some of the researchers consider the t-value, while some of the researchers consider the significant value. By rule of thumb, if the t-value is greater than 2, it means that this is statistically significant, or if the this significant value actually shows the p-value. If the p-value is less than 0.05, it means that the result is statistically significant. It means the mean value of the current students is statistically different than the mean value of the tested, which was equal to 50. Now if you check the result criteria, as I told you, if the p-value is less than 0.05 or equal to 0.05, then you are supposed to consider the alternate hypothesis, which shows that the sample of the students, the sample of the marks, mean sample of the marks is different than the 50. So in this case the value is less than 0.05. We will consider the alternate hypothesis. You can see that the p-value is less than 0.05. Let us check on another way. If our target mean was the 70.6, it means that then there will be no difference. It shows. Let us check it again. Compare one sample t-time. This time I am going to change the target value. I am comparing it with not with 50, but I am comparing it with the 70. Now you can see that on average the students' marks is 70.63, and if this is our target with which I am looking whether it is different or not, so of course the result will be that the mean of the sample is almost same to the testing figure. If I click on OK, now you will find again that now you can see that the p-value is this time greater than 0.05. if the p-value is greater than 0.05, it shows that the null hypothesis should be accepted, which shows that the mean value of the sample is equal to the tested value, which in this case we have tested it with the 70. So if you see the mean value is also 70 of the sample, and our target was also 70. That is why there is no difference between the mean value of the students' marks. So it also shows statistically that it is the insignificant, and we are supposed to consider the null hypothesis in this case. Thank you, students.